Great. Well, first off, I'll just give you a quick outline of where we hope we're going to take everybody on this talk. First off, I'll start off just describing what it is exactly. A few slides talking about the process and how the database and package are actually built. There's quite a few slides on what you need to know if you want to use it. Stocking and quota tag information is deceptively complicated, and we have to make some decisions that we want to clearly articulate. And then finally, talk about the annual report. So the report we've been asked to produce on an annual basis, obviously, in time for this meeting. So we'll quickly go over the elements of that. Before I get too far into it, though, I really want to acknowledge all of the contributing agencies around both Lake Huron and Lake Michigan who allowed us to provide their data through the land for submission or stocking submission to the Great Lakes Stocking Database. Without everybody kind of buying in and contributing their data for this purpose, this wouldn't be possible. I think this is a really good example of a product that is, in my opinion, much more valuable than the sum of the parts. So what is it exactly? Essentially, it's a database of photovoltaic stocking and assessment recovery information that is compiled on an annual basis from the submissions that we provide with the GLFC through the U.S. Fish and Wildlife Service. And then that database is made available back to the community agencies. Ultimately, this allows agencies to easily answer really simple tagging questions that come up fairly regularly. Simple questions like, well, how old are these fish? What strain are they? Where and when were they originally stocked? These are the types of questions that I get asked fairly regularly in my office. And without a tool like this, they're actually deceptively tricky to answer, something very difficult. I've mentioned a couple times that it's a database. It's not actually a database by itself. It's more of a package that includes two Microsoft Access database files. One has a date stamp on it that indicates the date that the database was created or compiled from the data sources. And a second database that contains all of the queries that you might want to use. That allows us to update the source database without losing queries that the users might have added to their own version of the database. There's a folder or directory in there that contains documentation. At this point, there's largely presentations that I've given out to Lake Huron Technical Committee on this process over the last 2 years or so. It has a complete build script. This is all built automatically using Python. So all of the build scripts are included in the package. It's really kind of a philosophical decision that we made to make sure that all the information allows everybody to recompile it if they need to, rather than having it sequestered away in one place. There's a directory that includes several work examples. The work examples are in the form of R scripts that aren't really intended to be comprehensive analyses of anything, but might help somebody get started in using this and creating some useful product. There's simple scripts in there that allow us to create maps of all recoveries of particular photovoltaic tags, all the recoveries of photovoltaic stock in a particular area, all the recoveries of all the stocking locations of fish that were recovering from particular locations and various mechanisms on that. There's also another directory that includes associated resources. For the most part, these are just files that are required to make the examples fully operational and working. There's shape files like Michigan and Lake Huron, for example, so that the maps in the examples can be produced. And then similarly, there's the annual report and all of the source files again, so that it can be compiled by anybody who has a package on an annual basis if they ever need to. So how does this fit with the mass marketing program, or what about the mass marketing program? For those of you who were here yesterday, saw Matt's presentation. It was a really excellent presentation on all the work that the mass marketing program is continuing to do. As most people here know, that the mass marketing program works very closely with all the states around the lakes, and implementing large-scale tagging and recovery programs. We do really high-level analysis and reporting on those programs. We focus largely on lake trout, chinook salmon, and most recently steelhead. This initiative goes hand in hand with obviously a lot of the photovoltaic tags will be distributed in this database are ones that were deployed as part of part of the mass marketing program. Again, the intent of this database is to allow agency staff to answer those simple questions and not really delve into the high-level stuff that the mass marketing staff has. They have the expertise to really answer those big questions. So I'm going to talk quickly about the process and how this is built. Essentially, we have two data sources, existing data sources of data submissions that we all contribute to on an annual basis. We've got the stocking data and the lamprey wounding data that goes to TED. These are both submitted to U.S. Fish and Wildlife Service in Green Bay under the auspices of the Great Lakes Fisheries Commission. What we've done as part of this initiative is to write a number of Python scripts that take that information, validate it, make sure that it's reasonably clean as soon as we can get it, and then using some database tools, produce an access database that can then be used to generate all kinds of maps and analyses and, of course, the annual report. A couple of real strengths in this approach is that because it's scripted, it's can be repeated relatively easily. It only takes a couple of minutes to go run through all the scripts and recompile the database in the event that the data becomes available, for example. And the database tools that Python provide ensure data integrity and relational integrity in the end product. So it's pretty quick way to do it. The current status of the database as of this morning, we have data from both Huron and Lake Michigan, and there's currently 1,985 distinct code-wire tag numbers, and the first code-wire tag stocking event occurs in 1980, so it's got data from 1980 to 2016. There's 2,508 stock events by 8 different stocking agencies, so a pretty broad cross-section. And over 73,000 code-wire tag recovery events from 11 different agencies. I should say that the vast majority of those recoveries are later than you might expect. I think it's about 65,000 later recoveries. The rest of those include Chinooks, rainbows, some coho, a small number of Atlantic salmon, and then there's a few other data quality issues. There's a couple of Bovie that's not true that we're working with the community agencies to figure out. But they're still in there. The data sources, as I mentioned earlier, the actual code-wire tag deployment occurs from the Great Lakes Fish Stocking database. So the recovery information comes from the lamprey wounding that we all submit on an annual basis. But the mass marketing program has also contributed or promised to contribute some of the port sample and test information. Unfortunately, we weren't able to get it in the current version as of today. But we should be able to include it very shortly. So we look forward to that. And then there's a small number of patches that we've also included, and that's included in the package. And essentially these patches fix or add additional information that isn't available in the existing stocking database or recovery database. And these are largely associated with idiosyncrasies with Ontario stocking of sequential code-wire tags, and Ontario has actually stocked code-wire tags by different manufacturers a small number of times that need to be clearly identified. So the package will take care of that. Details about the database itself. One of the consequences of using a relational database is that you can end up with lots and lots of tables, and that's what we've done here. It's very highly normalized. Anybody who's seen the stocking submission to the Great Lakes Fisheries Commission knows that it's basically one big flat table. That's highly denormalized. We've normalized that and broken that down into all the elemental tables, essentially. The tables can be categorized into three kind of broad categories. Common tables, things like species, lakes, agencies, management units, they're common to both stocking information and recovery information. They're pretty straightforward, so I'm not going to say much more about them. But there's also a suite of tables that are associated with code-wire tag deployment and stocking. It's actually more complicated than you might originally think. And then there's a couple of tables that are associated with recovery that I'll quickly go over. In an ideal world, we would have one code-wire tag and then one stocking event. And it would be a one-to-one relationship, and we keep track of everything in a spreadsheet, a nice flat table. Unfortunately, that doesn't happen very often. Regularly, we have a situation like this where we have one code-wire tag being stocked in multiple stocking events. And those stocking events could be spread out in both space and time. And of course, the flip is also possible with multiple photo tags being stocked into a single large stocking event. And the only way we can accommodate all three of these different scenarios is with classic many-to-many relationship in a database. So it requires three tables. We've got a table over on the left-hand side that we keep track of all the information about our photo tags. Table over on the far side to keep track of information about stocking events or pipe in the water. And then there's a table in the middle that we call an association table that keeps track of which photo tags go with which stocking events. Unfortunately, Ontario and maybe some other agencies have used sequential photo tag, which means a photo tag isn't necessarily a photo tag. To identify those photo tags, you need additional sequence information. So to accommodate those changes, or that change, we actually need to have another table in that relationship. So the tables that are required to keep track of all the photo tag information include one for the code tags, which essentially describes a piece of wire. One that keeps track of the sequence. So if the photo tag doesn't have a sequence, by default, it will be start and end of the sequence will be populated as one, but the other ones will have the range to start first tag in the sequence range in the end. And then over the far side, we've got a table that keeps track of the stocking events with pipe and water, and then there's that association table photo tags to event. And between all four of these tables, we can capture all of the various machinations of photo tag deployment and stocking. We look at recoveries. Luckily, recoveries are quite a bit simpler. This is kind of a typical situation. We have some kind of a recovery event occurring here represented by a box of net. So it doesn't have to be a gill net. It could be a real sampling program or a derby sampling program or a commercial catch sampling, for example. We even have a few photo tags in there that people have delivered to our office directly. And that is kind of a prototypical example. And we might have multiple fish associated with that particular sampling event. Luckily, this can be handled with just the two tables. We've got a recovery effort and a recovery, which so recovery effort keeps track of kind of where and when it actually happened and by whom. The recovery keeps track of the biological information associated with the fish and the photo tag number itself. So if anybody compiles the data for TED, for the Lamprey winning submission, should recognize this. This is direct analogous and actually the field report is identical to the submission, the Lamprey submission, although the tables are named like years and biodata in the Lamprey submission. I want to say a few words about strains because, again, strains are a little bit messy. So we've got the table on the left, I guess, your left. The stocking event is the same one that we saw a little bit earlier. Then there's another table called strain raw, and the strain raw actually contains the information that is contained in the Great Lakes stocking database. Strain as reported in the Great Lakes stocking database is a free-form field, which is great because it allows agencies to put additional information in there that's meaningful to them, things like year class or origin, or whether it's domestic or wild, or the hatchery that it was raised in. But for my purposes, and for a lot of people's purposes, we don't necessarily need that to hold things up. We want one kind of common label that we can use. So this is how we've accommodated that by adding a second table that is essentially a grouper that makes those labels easy. So just by way of example, this is the information that's in the GLSC stocking database currently for contain the words Seneca. You can see there's all kinds of different versions of Seneca. So these would all be records that are in our strain raw table, and then the grouper table has one record associated with that strain, the label Seneca. So we can aggregate everything up by those simple labels. Users are free to modify this on their end if they want, but there are simple labels for all of the strains in the database. One of the other things that we wanted to make sure we did in the database was make sure the lat long was populated for every record, but of course it wasn't. So we identified how we filled in the lat long in both the stocking and recovery information with a field called spatial flag. Essentially it takes on 6 different values, and I got some quick math to try and illustrate those. The spatial flag is 1. A lat long was actually provided and the event was assumed to occur at that spot. If there was no lat long, but they provided a known site location. We can get lat long from that. We have a 5-minute grid, the center was a 5-minute grid, so there was no site or lat long. Similarly, we did the same thing. Spatial flag means best, highest level of spatial resolution with the center of a 10-minute grid. Spatial flag is the center of the management unit that was reported in. And finally, if the spatial flag is 6, it means that there was virtually no spatial information provided with the recovery or the stalking event, but we do know which lake it occurred in. And this allows the analyst to decide which records to include or exclude depending upon the question at hand. The results of flags in the table to keep track of or identify flag code-aware tags that have been compromised for one reason or another. Ideally, a code-aware tag is stocked in a single species strain year class, made by a single manufacturer and stocked by a single agency. That hasn't always been the case. So these flag fields make this explicit when one of those assumptions is violated. And there's a query in the database called CWT gray list that just compiles that into one nice type of package if you want to exclude all of those for one reason or another. This is an example of the typical output that you can get from it. It shows the map on the left shows all the recoveries of a particular code-aware tag number. There were offices off in the center of Lake Huron and subsequently recovered there in most of the main basin. Or you can generate or look at the biological information attributes associated with recoveries from a particular area, for example. In this case, it's age histogram by strain. These are all relatively easy to produce. One caveat about all of these output, particularly the recovery, in a lot of cases, sampling intensity or effort is really important to account for, and these two graphs serve to illustrate that point. The graph on the left shows all the recoveries from of Lakewood that were stocked in the mid-late Creek in the early 2000s. And this is, of course, Lake Michigan. And if you just look at that, you would think that there aren't very many recoveries, and the abundance is relatively low around the southern refuge, and most of the recoveries occur along the shoreline. Of course, that's not effort corrected at all. It's just a straight dump right over the database. And maps provide an effort corrected interpretation of the same information. You can see that you get a much different picture of what's actually happening with their after correcting for effort. You can see that the funds is actually much higher, the relative funds is much higher at the southern refuge. So just be aware that adjustment for effort can be very important depending on the question you're trying to answer. Finally, I'm just going to quickly cover the annual report. This is something that the Lake Huron Technical Committee asked us to see if we could produce on an annual basis. There were several copies available, and I have an electronic version if people are interested. If you take a look at it, it has very little interpretation, and that's by design, because it's essentially automatically created. We just specify the year and the lake, and it'll produce the PDF report. And that's about the only way we think we can do this. The stocking and recovery, the stocking and land data was only available at the end of last week, so there really isn't a lot of time to write a report that has much interpretation, but it does convey or contain the basic information. The basic information includes the number and location of code-aware tags stocked by species and agency, code-aware tags recovered for species, a little bit of information about the recoveries, and it also identifies problems. And I think it's important to identify the problems while they're still current, so we can get them fixed before they go stale. Once the data gets stale, it gets really hard to get it fixed. So if you look at the cover of the report, it gives us some basic statistics showing the number of code-aware tags that were stocked in a particular year, and how many were recovered by each species, the purpose and caveats of the report, and where the data came from. It generates a table of stocking events by location and species, as well as a map similar to the one on the slide. For each species that is recovered, it produces a figure like this. So it shows where the stocking events, where the recoveries occurred, going back to the originating stocking location, as well as a density plot showing the distance traveled, so essentially the density of all those connecting lines. And this is generated once for every species that's recovered. If there's only one species lake trout, most likely, then there will only be one plot, but if there are Chinooks and rainbow trout as well, there'll be 2 additional plots generated automatically. Similarly, a little bit about the recoveries. Typically, the thing everybody wants to know is the age. So we have age histograms, and again, the number of panels are automatically calculated and dynamically added depending on the number of species that are recovered. And for lake trout, because most of the recoveries are lake trout, people are most interested in lake trout, particularly the strains of lake trout, we create a multi-panel age histogram of the recoveries by lake trout strains as well to give a high-level overview of all the recoveries. And finally, there's a table in there that identifies basically unmatched code-aware tags. If you see it, and they're all sorted by agency, so if you see your agency code-aware tag showing up here with several recoveries, there's a pretty good chance that means that code-aware tag wasn't submitted to the Great Lakes stocking database or is incomplete in some way and should be added. Outstanding issues. Anytime we're dealing with a database this big from these many contributors, there's always issues with data quality. But I have to say, I'm actually really impressed. We started doing this last summer, and it took us a long time. Identified a lot of problems with the data, but almost all of the contributing agencies have worked really, really hard to get their submissions to the Great Lakes Fisheries Commission clean. When we scrubbed it last week, or merged this last week, there were far fewer issues, and most of them were associated with 2016, which means the historical stuff in most cases been addressed, but will be an ongoing issue if people start to use this more. There is an outstanding issue with species and strain. Again, this has just recently come to light. There's a couple of agencies that actually identified splake and backcross as a strain of lake trout. Most agencies, I think, identify them as unique species themselves. So we'll have to figure out how to address that in a unified fashion moving forward. But most of that is historical information. So if people using this as contemporary data, it won't be an issue. Missing code-aware tags. Obviously, if your code-aware tags aren't in the stocking submission with the GLC or in your submissions with the lamprey data, it won't be included in this database. It'd be great if you could get it. And there's an issue with species, code-aware tag species mismatch that has come up a couple of times. More recently, there's some large stocking events where they were stocked, I believe, with Chinook salmon, all the recoveries were rainbows, or vice versa. So I think the stocking events are probably need to be updated to reflect what the recoveries actually were. And historically, there's some issues with Ontario's data where we stocked splake, backcross, and lake trout in close succession. This means I'm done.
Keep going.
We're almost done. Where you can get it, it's going to be compiled annually, moving forward from both the stock and lamprey data, so that data is available or submitted to be submitted February 15th, typically, which means that we should have it available, database and package available, hopefully early March, definitely in time for this meeting. We get the annual report at this meeting. If you would like to get a copy of the database and package, the entire package, it should be available from anyone on the presentation office. So maybe leave it at that.